Yeah, we do have new notes. So the next set of notes.
I was right.
Are we going to finish these notes?
Maybe.
If we do have time, which I doubt.
Hey, is the launch on there the hockey player problem?
Yeah.
Yeah.
Because there's a hockey guy.
Anyone know Mr. Roman? He was our gym teacher here, principal.
You want to hear a funny story I found out the other day?
What's that?
So my cousin went to Perry.
Okay.
He's in the Navy right now. And so he had to put on a primary source in case he died. And
You put Mr. Roman?
he put Mr.
That's
Roman
awesome.
as a primary source
Yeah,
that
like
wasn't
emergency
his
contact.
relative.
Yeah. That's fine.
Mr. Hudson, here's your notes.
Thank you very much. All right.
With the page.
Do you know Mary Moyer?
Yeah.
She's my
I taught
cousin.
her. I know. She's trying to get babysitting jobs, isn't she?
Yeah.
I saw that on Next Door.
I don't have to.
All right. I need your attention up here. Oriana, what's up? I got it
Do
already.
you want another note?
Nope, I'm good. Either put them in the folder or put them back in the bin. Actually, don't put them in the folder yet, because I don't know if we'll get that far this afternoon. Our new folder's right here, dude. We're pink always. But if you care. All right, I need your attention if we're going to make it through. We got 20 minutes. Oriana, question.
Is 10 formal?
Yeah, but I'll give you a work day tomorrow. So it's kind of homework. It's practice that's assigned and due by like Monday-ish, probably Tuesday more so. So, trust me, this homework's going to be fast. If you guys are good at problem solving, or if you guys mastered equation solving, that's all both of these homeworks are, is equation solving. Set up the equation. Two chapters ago. So chapter 8 was the equation solving. So, when you play hockey, if anyone's ever played hockey, you've got your hockey stick. Now, when you're skating down the ice, it doesn't really matter how your hockey stick is positioned. A lot of times you might even see them, going back and forth trying to confuse people. But when you go to shoot on the puck, what's important about the placement of your stick? Brendan?
It has to be close. It can't be all the way up here. It has to be
Yeah, what if I crouch and go to shoot? What would happen to my hockey stick if I crouch? It's gonna get at a weird angle. Isaiah, what do you think?
It will the end of it will go up.
Yeah, if you've ever seen a hockey stick actually, the end of it has a big fat part to hit the puck. If this hockey player crouches and brings the stick down, the front of the stick's gonna come up. So what we're really saying is it's important when a hockey player goes to shoot that the end of his stick is flat on the ground. So this makes a straight angle with the ground. But what we want to talk about then is what angle exists between the ice and his stick this direction. Well, we see that they've labeled that angle to be 45 degrees. I kind of wrote on top of it. So if this angle here is 45 degrees, what is the angle made by his stick? Let's say that we are designing a new hockey stick. We want to determine what angle should be here. They're calling it the lie angle, the angle of the stick between the part that you hold and the part that you hit the puck with, which I really should just get a hockey stick.
I have a hockey stick.
How do we figure that out? Well, what do we know about ice?
It's slippery.
Okay, it's slippery.
It's very cold. It's flat.
It's what's straight, so flat. So if I started here and went to here all the way, let's cheat. How many degrees would that be?
180.
180. So these two angles are going to add up to 180. What would it take to get to 90? 45 more. And then if I have another 90, I just add those guys together, and I get that this angle would be 135 degrees. Yeah, Layla.
I subtracted 45 from 180.
That works perfect. Yep.
Wait, so we did 45, 35.
Now the other way that Layla just brought up is the fact that she knows ice is flat. So she knows that the 45 degrees plus the unknown angle, we'll just call it L since they called it the lie angle, has to equal 180 because the ice is flat. So what Layla did, because it's flat, anything that's flat is 180, it's a straight angle essentially, because we're giving it a vertex right here. So to go all the way from the ice over here to the ice over here, it's going to take 180 degrees. So all Layla did was subtract 45 from 180 and got 135. Right? Should be. Oh, let me minimize that window.
I just write 4.
So now I'm not going to use Pearson for this. We're just going to work through the lesson. So 2 angles. We always have angle pairs when we're talking complementary or supplementary. We're always discussing pairs. Their sum has to be 180, or you could say their sum forms a straight line. Some people, that really helps them to remember to think the sum forms a straight line. So I would, if I was you, because I did not get it typed into these notes, off to the side, write, you take supplements.
Take supplements to get bigger.
Yeah, I ran out of space for supplements, but you take supplements to get bigger. So that can help you remember it's the bigger pair of angles. Supplements are the 180. Or think of like, there's some macho man bodybuilder or something, he takes supplements and he weighs 180 pounds or something. We've had, yeah, dude in Despicable Me. He probably takes supplements. So, easy pair of adjacent supplementary angles would be 2 right angles. If I have a 90-degree angle against a 90-degree angle, that makes a straight angle. It's like this wall. When this wall is shut, it makes a 90-degree angle. But when we open it, and the wall, if you imagine the wall to disappear, that 90-degree angle just continues on to Mrs. Goldring's room and makes the whole straight angle, or the straight line of the wall. Now, what if we don't start with a 90? What if we start with a 160? What angle would be supplementary to that, Thomas?
20 degrees.
20 degrees. Now, you could draw it here, but I'm going to be weird just because I like it like that. And I'm going to draw it here and label that 20 degrees. And yeah, that was already written here for you. Because this angle sitting over here, the reason I didn't draw it on the right side, like complementary angles, supplementary angles don't have to be adjacent. So this angle that is adjacent could be its supplement, or this angle that is not adjacent could be its supplement. Because imagine if you took this, I'm going to call it the red angle, BOC, and you slid it over, it makes a straight line when I put the 2 angles together. Now this again, and I tried to take us to this yesterday, this is where the vertical angles come in. Now angle A, like the blue angle and the red angle, now those would be vertical. They're both 20 degrees because they share the vertex and both sides. So that will be probably like Monday's lesson, because I thought vertical came before the angle pairs, but I was mistaken. Oh, I didn't get it typed in your notes, but when I went back and I went back and edited the notes, so now it is in here. Sorry, guys.
Well, it's not on our paper.
I know, I went back and edited them.
To these ones, I got it.
I'm sorry. So, draw your adjacent angles and label how big they are. I'm going to give you 30 seconds. Adjacent supplements. So they have to sum to 180.
Oh, I did it. Wait, what?
An adjacent supplement. Adjacent means it has to share the vertex and the side. So adjacent supplement. Katie, now that you're back in the room, how big, actually you can choose which one you want. You want A, B, or C? C? How big would a supplement for that be? What does this symbol tell me about, bless you, about the size of this angle? It's 90, so its supplement it would have to be 90. So if I continue my straight line on, I can give it the 90-degree angle, and I can say, hey, you're 90.
Mr. Hudson,
Yeah.
even when you say that, you could say like 90 grams or something.
What?
90 grams is something.
No, degrees. It's got to be degrees.
No.
All angles we're
It
dealing
could
with
be
degrees.
like 90.
All right, Cassidy.
What?
A or B?
I choose A.
A. How big would the supplement to A be?
Oh wait, can I draw it on the board?
Sure.
Yeah. City. Okay.
And nope, Franny's sick. Franny, feel better. Oh no, she's taking matte makeup. Sorry, she's here.
One. I'll do the next one.
Eli, what about in B? How long? And actually, I'm gonna move your angle measure to right here because we like to put it in it.
I couldn't reach that high.
I got you. Eli, how big would my supplement be here?
Is it 15?
It is. It's a very small angle. And inside of there, it would be 15 degrees.
Good.
Now, here's my trick. If it's over 100, ignore the 100 and just think 65 plus what takes me to 80. Because it's supposed to be 180.
Or you just do 180.
Yeah, you can just do 180 minus 165, but the hundreds cancel out then. So it's the same thing. All right, in this got it, write out the equation, I gotta see an equation, and solve it to find the supplement, and I want you to tell me what it would be named. There are two options for what it would be named. I'm gonna go ahead and tell you your fourth point will be D. We'll use our fourth point will be D. Well, when you make a new angle, you have to have a new point. So our fourth point will be D. So if you imagine ABC, A, B is my vertex, and C, I gotta try to make it about 48. So C is up here. Try to not look up here. I'm gonna write some stuff. Try to not look up here. Try to work on your own.
I can't do this.
Yes. Well, no, you don't need one. Oh, you're trying to be like really perfect?
Yeah.
Sure, get a protractor.
I'm perfect.
Oh gosh.
Good.
I believe you should have this as your answer.
Yeah, I got that.
Now, the only other option here, you with me, gentlemen? The only other option here is if instead of following this line, I followed my line CB and came down here. I'm going to now actually call that, well, if you did that, that'd be D still, but I'll call it D prime. When we have 2 points with the same name, we start to use apostrophes to differentiate them so I know what is what. And that angle would be A, B, D, or D prime in my case. And that would be the same thing because it also would have to be supplementary with it. So remember, we can always go on either side of it. Or, since it doesn't say adjacent, we wouldn't even have to touch it. But it's easier to draw if we make them touch. Because it's easier to draw the straight line. Cassidy? You good? You sure? Set up an equation to solve for this. I'll give you 45 seconds.
Okay.
we solve the equation too?
Oh, yeah.
Oh.
So when I say set up to solve, it means go ahead and solve it once you get it set up. 20 seconds. The spine.
We should film a spy movie here.
Discovery Book.
We could be
Give
like
them that
civilians.
All right, Crystal.
I'll be thinking of first.
What equation did you set up?
I think 2x is 50. That's my
Hey guys, there's a lot of like just chatter. Knock it off. You're disrespecting your classmates. 2x plus 50 equals 180. My two angles must sum to 180. Layla, what would I do first? Get rid of that 50. Then we find out that 2x is equal to 130. Oriana, what do I do next?
Divide by 2.
We divide by 2, and what'd you find for your answer?
90 or no, 70.
Break it up. What's 100 divided by 2?
50.
50. 30 divided by 2.
50. Oh.
Ah, so x here equals 65 degrees. Now notice, when I plug that in, what is the actual measure of this angle? And notice what color I used. The 2x. The 2x right here in my equation tells me it's 130. So if I go to label the angle, it's 130. But x is 65. Does that make sense? That the variable you find is not always the angle size, it's the variable in the angle. We're going to try one more of these, make sure we're good. Dude, got it. I'm only giving you 30 seconds.
Let's do this.
We're running out of time. Hopefully setting up the equation is not difficult for you at this point. We know we take the angle measure of my one angle, add the angle measure of my other angle, and they will equal 180. You have 10 seconds remaining. Sorry, I don't determine how fast time goes. There's ice in here. I like my coffee cold. In the morning I like it warm, but when I get here I get hot. So I want to cool it. And time! Divine, what do I do first here in my equation?
You subtract by 74.
Yeah.
It equals 106.
Alright, hold on. Moving quick. 4x, hold on, you're moving too fast for me. 106. Alright, then what do we do?
And then you divide by 4, and then you get 26.
Anyone verify that? Divine, you got 20.
6.5.
6.5. Now, we don't need the degree symbol on there because it's not degrees, it's a variable value inside of a degrees. So again, this angle here would actually equal the 106. But the x then equals 26.5. Thank you guys, that's all we got for today. Tomorrow we will have a work day so that everyone can get caught up before we take our mastery.